Hello guys, welcome to SkillMiner aptitude course. Today we are going to see the topic permutation and combinations. Now first I am starting with the topic linear permutation. The topic permutation is divided into two models. Permutation is divided into two models. First model is linear permutation. Okay. Second model is circular permutation. Now we are going to see the problem on both models one by one. The first question is based on the model linear permutation. Linear permutation. This is also called as factorial permutation. Okay, linear permutation also called as factorial permutation. First we can go to the question. How many 10 letter words can be formed with all the letters of word engagement? In question they have given the word engagement. Okay, this word engagement consists of 10 letter 1 2 3 4 5 6 7 8 9 and 10. They are asking how many 10 letter words can be formed from with all the letters of the word engagement, which means the 10 letter. I am giving some examples. For example, you can form NGAEGEMENT. Okay, this can be one of the word, or you can reverse TNEMEGAGNE. Like this, there will be n number of probability. N number of probability. Okay, in short, there is a formula to find the number, which is 10 factorial. This 10 factorial indicates the total number. Totally, there are 10 letters in the given word divided by the factorial of numbers which are repeating, which means in the word engagement, the letter E is coming 3 times. 1 2 3. Okay, so I am keeping 3 factorial into n is coming 2 times. 1 2 2 factorial into G is coming 2 times. 2 factorial. Okay, so how I am forming this answer? Numerator will be total number of letters, that is there are 10 letters in the given word. 10 factorial divided by the product of factorials of repeating letters, that is product of factorial of repeating letter, which means E is coming 1 2 3 times, so 3 factorial. N is coming 1 2 2 factorial divided by into G is coming 2 times, 1 2 2 times, so this will be our answer. Okay, this is one of the example of linear permutation. Now we can move to the second question. If all possible words using the letters of a word draw are formed without repetition and rearranged in alphabetical order, what will be the position of word ward? Okay, same concept, guys. There is a four letter word called draw. In how much possibilities we can arrange this word? That is 4 factorial. Okay, 4 factorial indicates 4 into 3 into 2 into 1, which is equal to 4 3s are 12, 12 2s are 24. In 24 methods we can rearrange the word draw. Okay, in question what they are saying, they are rearranging the word into 24 possibilities. After rearranging them in alphabetical order, we should find the position of word word. Okay, now the first thing to observe here is what are the letters given here? D, R, A, W. Arrange them in alphabetical order. So first the word A comes, letter A comes, then D comes, then R comes, and then W will come. Okay, here as per alphabetical order, A comes first, D comes second, R comes third, W comes fourth. Okay, here in our question they mention the word ward. The position of word we need to find. Okay, since the total possibility is 24, total possibility is 24, total letters are 4. From each letter a starting letter, we can form 6 words. Okay, that means starting from A, 6 words are formed. Starting from D, 6 words are formed. Starting from R, 6 words are formed. Starting from W, last 6 words are formed. So this word will be the 24th, this will be 23, this will be 22, this will be 21, this will be 23rd. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So starting from 20, if you arrange as per dictionary, next letter will be A, D, R, and then W, A, this will be 19th, 20th, 21, WA, R, D, W, DAR, WDRA, WRAD, WRDA. Okay, since these words are arranged as per alphabetical order. Okay, so the word we needed, which is in 20th position, so our answer is 20th position. This is the our answer. 20th position will be our answer. Now we can move to the concept circular permutation. The question is, in how many ways can five friends sit around the table? Okay, if this is the linear permutation concept, you can directly write 5 factorial as answer. But this is a circular permutation, so you cannot simply write 5 factorial, it will be wrong. You need to write n minus 1 factorial. This is the formula which gives us 5 minus 1 factorial, which is equal to 4 factorial, which is equal to 24. 24 will be our answer. For linear seating, we can write n factorial. For circular seating, our formula will be n minus 1 factorial. Okay, now we can move to the next question. In how many ways can 4 boys and 4 girls sit around a table if no boys should sit together? The condition is no boys should sit together, which means boy 1 is sitting here, boy 2, third boy, fourth boy, girl 1, girl 2, girl 3, girl 4. The condition here is no boy should sit together. So what I am doing, I am fixing a place of one boy. I am fixing one boy's place and I am rearranging others. Okay, so what will happen now, since I am fixing boy's place, these boys can get alternated only in these zones. Okay, since I'm constraining boys position, boys probability will reduces into 1, but girls can wander anywhere in these 4 position, so the girls seating arrangement is not restricted. So our answer will be 4 minus 1 factorial into 4 factorial, which is equal to 3 factorial into 4 factorial. This will be our answer. In an elaborate way, it can be said as 3 into 2 into 1 into 4 into 3 into 2 into 1, which is equal to 3 2s are 6, 6 4s are 24 into 6, 6 4s are 24, 6 2s 144. In 144 ways, we can change the seating arrangement. Okay. In how many ways can a bracelet of 10 different beads can be made? Guys, for a bracelet or necklace or garland arrangement, our formula will be n minus 1 factorial divided by 2. For this type of problem, formula will be n minus 1 factorial divided by 2. Okay, this is the formula we need to follow. Since the number of beads is given as 10, we are substituting that in formula, that is 10 minus 1 factorial divided by 2, which is equal to 9 factorial divided by 2. This is our answer. Okay, for a garland or necklace or bracelet type problems, follow this formula. Next, we can move to the topic combinations. How many diagonals does octagon have? Octagon consists of 8 sides. Okay, their diagonals can be in many number of ways we can draw the diagonals of a octagon, since the sides can also be contributed to diagonal. Okay, the sides of shapes can also contribute to a diagonal. So to find the diagonals, first what we have to do now, how many total drawings lines can we draw on octagon? That is given by n c 2. Okay, this is the formula for finding total number of lines. Since octagon is having 8 sides, 8c2, which is 8 into 7 divided by 1 into 2, 28. 28 number of lines can be drawn in a octagon. So since side of a the sides of a octagon can also contribute to a line, for finding diagonals we should minus 28, we should minus these 8 sides from those lines, which will gives us the value 20. So there are 20 diagonals octagon have. Okay, 20 is our answer. Similarly, how many diagonals does hexagon have? We know that hexagon is having 6 sides. So number of lines is given by nc2. Here 6c2, which is equal to 6 into 5 divided by 1 into 2, which is equal to 15. 15 lines will be in hexagon. So diagonals will be 15 minus 6 sides. 6 sides of a diagonal hexagon, which will gives me the value 9. So there are 9 diagonals in a hexagon. Okay, now I am drawing those diagonal. 9 diagonals I am drawing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 diagonals that I can able to draw in the hexagon. How many diagonals does decagon have? We know that decagon have 10 sides. So number of lines will be 10c2, which is equal to 10 into 9 divided by 1 into 2 is equal to 5 nines are 45. So diagonals will be 45 minus 10 side, which is equal to 35. So 35 will be our answer. In a class of 25 students, find the total number of ways to select two representative. Okay. In a class of 25 students, number of ways to find two representative will be 25 C2, which is equal to 25 into 24 divided by 1 into 2. 1 time 12 time. 25 12s are 300. There are 300 ways to select two representative from a class of 25 students. Now, in the second subdivision, find the total number of ways to select two representative if a particular person is not selected. Since they are given that particular person, that is one person is not selected at all, our answer will be 24 C2. From 25, it is getting reduced to 24, which is equal to 24 into 23 divided by 1 into 2. 12 time. 12 into 23, which will gives me the value 276. This will be our answer. Okay. Now I am moving to last question. The number of ways 10 books distributed among 4 students, S1, S2, S3, S4, such that S1 and S2 gets 2 books and S3 and S4 gets 3 books each. Okay, guys, there are 4 students, S1, S2, S3 and S4. Here S1 and S2 are getting 2 books. S3 and S4 are getting 3 books. So totally there are 10 books. Okay. 2 plus 2 plus 3 will gives you the value 10. First, there are 10 books. I am giving 2 books to S1. Okay. That's all. 2 books getting over. Now 8 books are there. From this, I am giving 2 books to S2. Okay. Now this 8 book is reduced to 6 books. Now I am giving 3 books to S3. Now the 6 is reduced to 3. Last 3 books I am giving to S4. So 10 into 9 divided by 1 into 2 into 8 into 7 divided by 1 into 2 into 6 into 5 into 4 divided by 1 into 2 into 3 into 3 into 2 into 1 divided by 1 into 2 into 3. Guys, you want to see the numerator. The numerators 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 1 is a 10 factorial. Okay. Denominator you see. There are 2 factorial and 3 factorial. This will be our required answer. Okay. Thank you.